Hi everyone, thanks for tuning in. It's Professor Smith, and I would like to go over a couple of probability, specifically Bayes rule problems today. I'm starting you off here with number 4 in homework 2, and you can press pause and read the question. I had clicked on these cascading boxes before I started this video to open the data in Excel, which I have right behind me here. So the first question is asking, what is the probability of a false positive? So that means the drug test is positive, however, the user is not a drug user. So I have my data right here, and the first thing I want to do is total my rows and my columns, and I should get the same total for both. So if I add 46 and 10, which are the two results for users, I get 56. And when I add the two results for non-users, whoops, I get 36. And when I add these two results, I should get 92. Now I'm also going to do the same thing for the positive test result. Actually, I'm not doing exactly the same function, but I'm performing the same operation with plus and sum commands. And you can see that 48 plus 44, the total positive and negative test results, also sum to 92, the total number of results. So let me make this just a little bit better to look at. And so when I bounce back to the question, it is, what is the probability of false positive? So positive given false, or do you think it would be false given positive? False positive would be the intersection of false and positive. So going back to the data, false positive would be a positive test result for a non-drug user, because non-drug users should not test positive, and when they do, that makes it a false positive. So you can see here there are two positive test results for non-drug users out of a total of 92 results. And that should reduce, and I'll leave that to you, but I'm going to type into my calculator, or actually I'm going to see if it will take my 2 over 92 as an answer. Nope, it says round to 3 decimal places. So I don't even need to reduce the fraction. I could just type 2 divided by 92. It gives me 0.0217. So to 3 decimals, that is 0.022, which, yay, is the correct answer. That's excellent. And who would suffer from a false positive? I'm going to leave that one for you to read over, and I'm going to move on to number 8, which is the other question that I wanted to go over with you, especially before the midterm. So number 8 gives me different blood types and groups. So the types are positive and negative, and the groups are the letters. I would like to open this in Excel. And we have A or positive, probability of type A or positive. So I'm going to open this in Excel for real this time after I've saved it. And I'm going to start this problem the same way. I'm going to add up all of the rows individually. here I'm using the sum function. And then I'm also going to add the columns individually. And if I did this right, this 131 should also be the sum of all my columns. Let me just double check that for you. Yes. So 131 is the total number of subjects or respondents in this case. We're looking for the probability of A or positive. That's going to be equal to the probability of A plus the probability of positive minus the probability of A and positive. Because these two events are not mutually exclusive, they overlap. We need to subtract off the A and positive that were counted twice already. So we got the A's here and the positives here. But in that, we counted the A positives 2 times and therefore have to subtract it off 1 time in order to count it correctly. So I have the probability of A is 47 over 131, and the probability of positive is 98 over 131. So here in the probability of A, that is all of the A blood type divided by the total, excuse me, and here the probability of positive is all of the positives divided by the total, and the probability of A and positive is 35 over 131. So in order to plug these in, I'm going to add 47 and 98 and subtract 35, and I get 110 divided by 131. And when I perform that division in my calculator, I get 0.83969, which I'm sure my labs will ask you to round in some fashion. Oh, integer or simplified fraction. 110 divided by 131 does not reduce. And well done. And they are not disjoint or not mutually exclusive because there is an overlap or an intersection. Thanks for tuning in. Have fun with your homework. Stay healthy and have a great day.